Welcome back. Another edition of Open Line Friday. In fact, we only have two left for the rest of the year. And this is one I've requested for a little while now because Chris is actually one of my favorite people to talk to. And don't tell the other consultants that. I requested you from the time that you did the last Harness ProD Open Line Friday last year
So
because
kind.
low key, you're probably the funniest guy at EPLAN. Don't tell the rest of the staff I said that, especially Alessandro, because I'll
That's a
get in
sad
trouble.
statement.
But
If I'm the funniest person at EPLAN, then
so Christopher Alldritt is one of our consultants here, and you're out of California.
yep.
And really, you're the guru, bro. You're the Harness ProD guru. I don't know how that came about, but tell us about your time at EPLAN so far.
No, I'm the Harness ProD guru because we have nobody else who is interested in Harness ProD. That's not true. I'm the Harness ProD guru because I specifically wanted to learn as much about harness as possible because I wanted to really see how electrical designs would work in the 3D space. And ProPanel is a wonderful tool. It's great. It's just not as good as Harness when it comes to actually seeing your designs, working with your designs, and making sure that all the parts fit in the semi-real world called the digital twin.
Okay. Now, what's the application for harness? What do you see it most used in, or what when you're consulting? Who do you talk to? You don't have to say names of companies, but what industries?
Well, really, originally, harness was designed for vehicles, so automotive, ships, or shipbuilding, and maybe special vehicles. And we've got a few examples of those. But the idea was how to run an incredibly complicated set of cables and wires through a vehicle. And once you have that routed, you want to be able to explain that to somebody else and hopefully replicate that design without running it through the cable every time, because that would take forever. So, little history. The original idea started with a just creating a nail board, a virtual nail board. When a nail board is just a big flat object, and you just attach connectors to it, and you route objects between those connectors, and then you mark down what you did, and then you take that nail board in the form of a drawing or just in the form of some marks on a pegboard and give that to somebody else so they can replicate it over and over again. The harness product that we have now allows us to skip that portion and route directly into existing CAD. So we can take a new design and route that through a vehicle. We can route that through maybe a small enclosure. We can now route that design through a manufacturing cell or a large machine.
Gotcha. And Platform 2024, I know that we've been talking about this, has some enhancement to the product. So we'll get to that in a little while, but I wanted to find out from you. Let's get an idea of really what you do on a weekly basis whenever you're covering harness, when you're talking to clients, to customers.
Primarily what we do is we look at what they have, which usually involves some 2D drawings, and then we look at where they want to go, which is a fully rendered model of their harness inside inside an existing project that they've done in a 3D CAD application like NX or Inventor, et cetera, any 3D CAD or any 3D assembly. And we have to get what they have on that 2D drawing into the 3D model and then back out again in the form of a document that is accurate, is up to date, and I guess most importantly, that somebody else can understand and then replicate that work. In addition to that, there's the ability to create a bill of materials for that entire design that's also up to date. And so that eventually the purchasing department has a list of the correct parts to buy.
Mm-hmm.
And what we want to do with harness and our platform product is link the two. And we now have the ability to create a bridge between what's going on inside a schematic program like P8 and place that inside of harness, and then finally back out in the form of some schematics and other derived drawings.
Perfect. Can you show us some of that?
Yes, I can.
Excellent.
All right. So
I
we're
like
going
to see things.
all
They
right.
have pretty colors in harness.
So we'll start with the basics. So when you start harness, and you have start off with a nice blank space, and the first thing you want to do is import some CAD. So bring in a very simple CAD drawing, just a basic cube design. And we have our cube, our quad cube, and we want to start routing parts around inside of it. So we'll go and grab some parts. Our library, which is connected to EPLAN's library, allows us to bring in parts directly from the data portal to P8 and then directly to the harness. And now with the advent of the LPM product, we can skip P8 altogether and bring in parts directly from the data portal to LPM.
Wow.
And then eventually to harness. So we have this, and now we want to add a cable. Let's bring in a cable, place cable, and let's look for a nice SICK cable. Connect here, connect there. And so now we're immediately given a dialog asking us, okay, which wires on this connector side, what coded, which wires on this connector side. We've got brown, white, blue, and black attaching to the connector pins on both sides. Click OK, and now we've got a cable. That's wonderful, but now we eventually have to get it through all the twists and turns inside this little quad cube. So we'll introduce what's called a bundle. A bundle is a virtual path which allows us to guide our wires and cables. So we'll start with a bundle, and we'll place the first bundle point on the surface here and just work our way through the design. And then let's go way up and see. All right, so now I've created like a very basic bundle. So now we want to route this cable through that bundle shape. Depressing as it is, we'll go to the route and then just click auto route into bundles with a cable, and then it automatically links. Now I've got, because it's me, because I did this in a hurry, I've got a bunch of little errors telling me that I've exceeded the minimum bend radius of the cable, and I can tell that by going to tasks and then running the task report and saying bend radius exceeded, not connected to any pin, not connected to any pin. Chris, you've done it all wrong. So you can go to each individual point and solve that by correcting pins, making sure that the red goes away. All right, so that is the very basics of harness.
So can I ask you this? Not knowing me, being a person that's never used harness before, whenever you had those little points that you could pull up and down with harness, are those automatically generated? Those points of I don't even know what they're called, but you know, it seemed like that was the actual point where you can manipulate that wire. Are those automatically generated, or can you insert those in different places?
Josh, I'm so glad you asked me that question. I cannot tell you how much. These are called control points, and you can add as many control points as you want to, and you can get an idea of where you are in space with the little online annotations that pop up, and you can drag and twist and run points everywhere.
Huh. Okay.
So eventually what you're going to do is move on to something a little bit more sophisticated, like say a chiller unit. So we have a chiller unit here. And what we would like to do is run some cables through this chiller unit to get a better look at this chiller unit. We'll access one of the views available to us. This is what it looks like from the top. And what I would like to do is run cable from here, down here, and eventually down to the motor.
Okay.
So, and instead of using connectors from the library, what I'm going to ask Harness to do is link to an existing EPLAN project. This is the ESS sample harness Gillette project. So it's designed to make sure that I don't screw up. I'm going to defeat it anyways and probably embarrass myself. But to start out, we're going to take a look at the basics of what's going on inside this harness unit. So the in EPLAN or P8, this is the P8 schematic program. We're going to connect this cable called W1 to XD19. That's this plug attached to the motor. To XD12, that is a connector attached to this power circuit board. And this little ring terminal here, you don't know it's a ring terminal yet, but it's a ring terminal connected to a ground. And so what I did in advance was I linked all this stuff to this special dialog in PA called wire harness dialog. Guess what that does? That takes all that information and sends it to the studio or the harness studio product. So what we're going to do next is make sure that all these products or all these little individual devices, I'm not going to do them all, but all of these are linked back to that open EPLAN project. And so when we bring a device, what this device is going to do is look for this product back to a parts library. This parts library is attached to the same parts library that anybody who uses P8 is familiar with, the parts management library driven by SQL or our eCloud product called eStock, and synchronizes those parts with a 3D representation, which if you're familiar with ProPanel, you've heard of the 3D macro. And so the same 3D macro parts can be imported into Harness without really doing anything other than clicking import parts into Harness. So we're going to do that. Sorry, long-winded way of saying we're going to import XD12 or place XD12. So just click on this placement item and bring an XD12. Now I've cheated, naturally, because I like to cheat, and I placed a mock-up of what XD12 is supposed to look like. I can turn on and off these little switches. It'll give me a little bit of an easier time placing the connector. So I'll place the connector first here. I'll rotate it around. It's placed in the wrong way. And now I'll link it directly to where it's supposed to be. Now in real life, of course, we can't cheat, and we'll have other items that'll help us along that we'll see later, called handles and points and et cetera, et cetera. But for now, we placed XD12. So now we can work down and place XD13. XD13 is that little ring terminal I told you about. Remember this over here, XD13.
Right.
So we'll go to this side and use this helpful little feature called a auxiliary coordinate system. So I'm going to turn off this surface and edges, turn this on. Too much technical talk, I know. But then I'm going to place this and it'll snap exactly to where it needs to be on the nut holding down, or what would hold down a ring terminal. I'm going to rotate that. Let's orient to the right position. And finally, our last thing to do is place what any electrical engineer will immediately point out is not an appropriate motor connector. I'm going to do it anyways. And place that directly on the surface of this box where it would never go. But the point is to show that the cable and all the connectors and everything else automatically is placed without having to run any sort of routes or doing any of that crazy stuff that we did beforehand. It's all been placed automatically because EPLAN and Harness know that all the parts have these little individual connectors on them. Those were established on the P8 side, and now that stuff is linked over to the Harness side, and we don't have to do anything else. So except for maybe route this wire. So we'll route this wire using path segments and route it into this. Notice how all the connectors are already aligned. With that. And then the only thing we have to do is route this cable. Now, Harness is smart enough to figure out that this cable would probably benefit by going into this particular bundle because the starting point here is close to that starting point there, and the starting point down here is close to that starting point down there. So Harness does the math internally and figures out I should not go through this other route on this side. I should just go through this one. So all I have to do is just click auto route into bundles, and then it automatically routes it from. So that is the link between the Harness ProD side and the existing P8 side. It's extremely easy. And
it looks like it's very intuitive, even.
I mean, as assembly tools go, Harness is very intuitive. Use the benefit of a space mouse, of course, but that's a product by some company. Any 3D mouse will work. And then everything else in terms of placing is pretty quick. It does not take a lot of time to learn Harness as opposed to maybe some other products. But anyways, we're not done yet. We still have to link this to a device, or it's not a device, we have a feature that allow us to spit this out in something that somebody who doesn't have Harness can read. So what we'll do is we'll take this and we'll add it to a particular group called a cable unit. And if we have a cable unit, we can create a cable drawing and then spit that out into either a PDF or maybe plot it on a printer or something that somebody can use for eventually to produce this harness. So we'll click that, say that is now part of that cable unit, and we'll highlight to make sure we've got all the parts. Notice that I highlighted everything on this cable unit is now yellow, but I've missed a few. I missed these little clips, and I want to include those. So I'm going to add these to that overall cable unit. And now, click OK. And now when I select this cable unit, I can hide it, everything else. And now I've got every unit should be included on this cable unit. And I can look at my my harness overall, which is eventually what we want to flatten. So we want to take this and flatten it out onto a 2D drawing. So we'll do that next. And we'll do that just by clicking on, I want a cable drawing. And it'll ask us, what cable drawing do you want? I'm going to say, I want it based on the name of the cable unit I gave in the last screen. So I'm going to look for this cable unit. I've got way too many, but it's fortunately the one up at the top, part of the chiller. And then I'll just pick the default configuration and I'll generate a cable drawing. Double click on my cable drawing. And that's it. I've got a nice cable drawing with some very basic to from information on both sides, and it's automatically dimensioned to the clips. This is why I included the clips, because I wanted to see what the dimensions are between each clip, and the cutoff length or stripping length between a connector and any sort of pins. And then you can also bring in other stuff like cables. If I wanted a bill of materials, bring that in. If I wanted, maybe not that big, but I wanted to see surface protections, I could bring that table in, all that stuff, and it's automatic and it always updates based on whatever is inside the drawing. If I changed anything and I want to go back, I can always, like a lot of our other products, you can right click and I'll just go to my source. I'll see where my product is. Zoom in. That's what I want out of a harness tool.
How much time saving is this as compared to the way it was done before? Because I mean, not only is this, like I said earlier, intuitive, it seems like someone that hasn't used this, that it's the intuitive nature of it makes it faster, but overall whenever somebody's working in this, it's really a whole lot easier to understand if you're new to this part of the business.
Uh, okay, so I mean, gonna show my age here, but one of the things that I had to do way back when I was a very small engineer was create cable drawings like this. And to create each cable drawing, first of all, you start out with a basis point somewhere, and then you would say, okay, from this point to that point, how far is it? So my options were to go out and look at the CAD, if the 3D CAD existed and the mechanical engineers bothered to even place a harness inside their 3D CAD. Odds are they didn't, because they didn't care, because it's electrical problems fault or people's fault. Um, fault. And then from there, if I didn't have that, then I would actually go out to the machine. I'm not joking. I would go out to the machine and measure each little segment, write that down, and then come back and then create my dimensions based off of that. And so I would take lots of pictures. And so a cable drawing like this, just this simple cable, and I did do this, it would probably take me closer to 45 minutes, because I would have to have a machine that was in assembly and had been routed. The old style way, it was we would, if we were too long, we would have the assemblers just wrap the remaining cable in loops. If we were too short, well, that was a problem. But if you can imagine routing cable around a machine like this, this is an example of a 2D lathe. Not a lathe, sorry, a 2D machining center. Sorry, Perforex. Lathe is the one that spins the workpiece. I was in machine tools. I know these things. But anyways, so if you had to route, if you had to figure out where all the cables were running, you had to go and find a system that was in mid-assembly and just measure the lengths. You couldn't necessarily take anybody's work apart, but you would have to get an accurate, and then you would always add a fudge factor of like 1.25 was a good rule of thumb, and then translate all that back to that drawing that we just saw.
There had to be
a lot
also,
of error correction.
I know that this gives you an exact length, but there was more waste at that point with wiring, right?
Yes, a lot. And more often than not, you would fudge in a direction that wouldn't get you screamed at. So if 1.25 came across as too tight, then you would add 1.75, and you 75% begins to add up in terms of actual money, because cables don't ever go. And that is like the worst case, yes, of course. And then as you honed in, you would get better and better. And then eventually towards the end of, say, a prototype, you would have, if you were lucky, you would have one machine that was completely wired, and then you would take all the wires off and then measure all those lengths. And then you would have a true length of every single cable and every single wire harness on a machine. Yeah, a lot of work. I think there was a study done recently about wire harness and excessive material from wire harnesses in automobiles. It was measured in the kilometers.
Whoa.
So figure kilometers. I mean, granted, these are very teeny tiny wires, because they're controlling all the, myriad sensors that are around a vehicle, but kilometers of extra wire inside of a car. The extra weight, the extra cost. Yeah, anyway.
From someone that's not inside the industry, and I don't know anything about wiring and about how wiring can, the effects of temperature on wiring. Do you have to allow for some kind of wiggle room for maybe wires that are going to be mostly in the sun as opposed to those that'll be in a colder climate?
Yeah, you do have to allow. I mean, the wires will get derated as temperature increases, and so the derating will have an effect on things like size the conduit, because if you have to derate a wire, then you have to accommodate for that derating. When I say derating, I mean things like voltage drop. In other words, if you wanted to get a signal from, say, a sensor down here on this chassis, and you had to route it all the way up and all the way down eventually until it got into this box. Extreme case. But if it was in a conduit with other wires, there is a limit to how many wires you can put into a conduit before you have to derate them. And when you derate them, that usually means that there is not sufficient voltage to actuate a device or trigger a sensor at or trigger a PLC going from 1 to 0 or 0 to 1. And that means that you have to increase the gauge or increase the conduit, and resulting in larger cost.
And that can be calculated in harness?
The size of the conduit?
Yes.
Yes. Yeah. So every conduit or every bundle in harness has the ability, let's see if it'll bring it up, to establish a fill ratio. So right now this is an empty one, so it's currently filled at 0%. Fill ratio is 100%. So, but if we would go on to another harness, in fact, we can do an example with an energy chain. An energy chain that you see right here is a series of interlocked plastic and metal crossbars that allow for linear motion along an axis. And so you lay as many individual cables and harnesses and surround them with protective material so you can bring either signal or power to a moving device. And so to tie that in with what you were asking about, promise I wasn't trying to avoid the question, we'll go into something called the energy chain, and we'll talk about yet another feature in harness. This is a new feature in harness that was upgraded from 2023 called the cable tray. And so a cable tray can be used inside of an energy train because we're not limited to rigid pieces of material inside harness. We can do whatever we want. So we can establish basically a rectangular bundle. And when we do that, we can establish fill ratio. So what I'm going to do is I'll build a basic cable tray. Let's see, it's the width, right? Yeah, it looks okay. And we'll place that thereabouts. And we'll lock our axis of X and bring this over to this side. Place one connection point, then switch to vertical mode. Going vertical, Josh. And finally end here. Now let's notice that the fill ratio right now is still 0%, but let's add in these cables.
Is there a suggested fill ratio for those? I mean, it can't be 100%, can it?
No, it's closer to around, depending on whether it's dynamic or static, and these will energy change, which will all be static, so it's probably around 70%.
Okay.
Let's create a quick copy and move that over. And now we can route this cable through this energy chain, like this, there and there. And now our energy chain is routed, our cable tray is routed, and now the fill ratio goes up to 1.02%.
It's possible to select all three of those and route them at the same time?
Yes, you can.
Okay. So again, just a much more efficient way of doing it.
Yeah, I just wanted to show one. But yeah, it's the same set of commands, auto route or semi-auto route. I don't want to do auto route because that'll grab everything, but let's just route here and then there, and now they're all routing. And now the fill ratio is going to increase. What you can also do inside of um, the cable tray feature is you can add in bundles. So you can add a bundle to a cable tray. And if you do that, the bundle has the ability to create specific classes, electrical classes. And so you can route different types of cable. Say that way you can separate your signal from your power by routing this group of wire or this group of cables through this particular bundle. And let's see. Out here and there, and those got right through, and now they're routed inside of a cable tray as well. So you can route within a route.
Gotcha.
So that's, and then of course you can use the cable tray again in the traditional way and just route a cable tray for use maybe in a cell. So if we create a cable tray here, we can start here, click this surface and start a route here, lock ourselves into X, and then route ourselves along. One of the things I wanted to show, and this came about because of a recent curiosity about how to better incorporate harness with mechanical design. So a lot of times the mechanical designs get incredibly complicated and they are apt to change a lot. So even the simplest little changes can have pretty significant effects on the overall design, not just electrically, but mechanically. So I was asked if it's possible to just do the harness design solely on the mechanical side and say, if you have some basic paths that you'd like to show and represent those on the mechanical side, how would you do it? Well, and if you export this information, you can get a neutral file and either a step file or VRML, and in that file, and I won't show the file, but there are a ton of little control points. And if you parse those control points, eventually what you can do is design from those control points. And so if we imagine that we're working on the mechanical side, and we've created the basic layout of a harness, and then we send that to the electrical designer and say, who has harness, and say, okay, go nuts. What the electrical designer can do is then just import the points. So we go to bundles and then we'll pull in a set of points. Pretty easy format. It really is, can be done in the CSV or just a text file, and we'll just address the points. So we've got our set of points. You can call them whatever you want, and Harness will understand them, but you need the XY coordinates. That's what you get from the step file. So normally you would export that off to Harness. But if you just want to export the control points, set that file up to just bring in the points. And then on the Harness side, we can adopt them into bundles. And then we've got a set of points that we can then use to place our connectors. And so if this is our harness, or this is what the mechanical designer sees, we can then bring in our connectors as usual and place those. I'll place a few of these. Just place them there, and adjust later. And then say the harness design changes, and there's that subtle little change that we talked about, and the CAD goes from this style, and if we zoom in, we'll see the changes, to this style, and all these little anchor points have changed.
Right.
Not exactly a big change, but it can affect the path of the harness, and we don't necessarily want to have to deal with all that. So we can just bring in the new set of points and see those changes without getting distracted by any of the excess CAD or having to worry about the additional step files. And now they've changed, and now they're just like that. Now they're just pushed over, very small change. Then on the harness side, once this design is finalized, then we can go to the actual CAD, the final design CAD, and then we can just bring in the same set of points to our CAD model. And then the points all line up. And then once we have that, we can bring in our either place our connector parts or bring them in a similar fashion. And then all of our connectors line up, and they're all exactly where they are supposed to be. And so that is a method that that both mechanical and electrical can use to coordinate between their various designs without having to use the entire massively complicated assembly or 3D geometry. So, and work just on the stuff that matters.
So I know that we covered some of the Platform 2024 parts, the changes that they had going into this new generation of EPLAN.
Yeah.
And I'm actually going to post the link to our website where you can see some of those for yourself. But I mean, this is actually very, very cool information. And I know that a lot of times people ask, well, how can I get more on this? You can either look at our YouTube channel. We have some more harness there, or you can get in contact with us and request Chris to do some consulting for you. I know that you'll have no problem with training and consulting on harness, because you're absolutely the man whenever it comes to that for EPLAN. So we appreciate you being with us today.
Absolutely.